All right, we are starting the last section of this chapter, properties of solutions, and here you can see somebody salting their sidewalk. And why does that work? It's because it lowers the freezing point of the ice. So properties of solutions, part 4, and here's a bag of ice. And we continue to look at colligative properties. We looked at the first one, vapor pressure one, and now we're going to look at the other two. So the second effect that happens when you add a solute is you get a boiling point elevation. It makes sense because you already learned that adding something to a solvent interrupts it from evaporating. Obviously, boiling point will be interrupted as well. So the normal boiling point of a liquid is the temp at which its vapor pressure equals 1 atm. Adding a solute will change that. When a solute is added, however, the temperature at which normal boiling occurs is interfered with, just like it prevents normal evaporation of the solvent. This causes the solution to require more energy input. More energy needs to be added to the system to get it to boil. Hence the higher boiling point. There's a little pot of water boiling. So the equation is delta T, change in temp, equals K lowercase m, which is molality. Delta T, of course, is change in temperature. This is for boiling point elevation. Lowercase m is molality, reminding you that it's moles of solute per kilograms of solvent. And Kb is called the molar boiling point elevation constant. And you get that from a table. The third effect that adding a solute has is freezing point depression. It lowers the freezing point, which is how salt on your sidewalk works. Some pretty icicles. So the addition of a solute changes the normal freezing point of a solvent by interrupting or interfering with the crystal formation that would normally occur. So it will not freeze as it did before. The equation for delta T is Kf lowercase m molality. It is a mirror of the other one. Delta T is change in temp. Lowercase m stands for molality, which is moles of solute per kilogram solvent. And Kf is the molal freezing point depression constant you get from a table. All right, here comes the example. Antifreeze, C2H6O2, is added to cars to stop cars from freezing, the coolant in the radiator from freezing up. It is also called ethylene glycol. We will need to have the molal constants for boiling and for freezing to solve this. There it is for the boiling, and there it is for the freezing. And the units are Celsius per molal, or molality. All right, so we're going to calculate the boiling point and freezing point of a 40% mass solution of ethylene glycol in water. You can pause and try stopping right now and doing it yourself. Or you can pause after each step. So step 1, since they give mass percent, you should change it to grams, really out of kilograms. We're going to be looking at it out of kilograms since we need that for molality. Then you're going to change that to moles. So 400 grams C2H6O2 from 40% is equal to 6.441 moles. For step 2, now we're going to find molality. You can pause at any time. All right, molality is moles of solute divided by kilograms solvent. We have the moles of the solute, and we can infer that 600 grams was water, 0.600 kilograms must be water. So we can do the math, plug and chug, and the answer is 10.74 molality. That's moles solute per kilograms solvent. Step 3, use the two formulas that we just showed you. And here they are, if you've forgotten already. Delta T, the boiling point constant times molality, and delta T for the freezing point constant times molality. Remember, this just shows you change in temp. So let's do it for the boiling one. And the answer is 3.3 degrees Celsius. Now determine the real boiling point. So the boiling point is equal to 100 degrees Celsius. That's the normal boiling point of water. Plus 3.3 is 103.3. Let's do freezing point. There's the equation, solving for the change in temp for freezing. And that is 12 degrees Celsius. So for the actual freezing point of this substance, we would do 0 minus 12 degrees Celsius, and that would equal to negative 12 degrees Celsius. So those are the actual boiling and freezing points. And this is the end of part 4.